So yeah, Buildkite is a scale-out delivery platform. You might be familiar with some of our customers. You've got like the likes of Uber, Slack, Airbnb, Shopify, just to name a few. These are the ones that we can talk about publicly, but there's a few other interesting ones that I can't. I would like to share, but I can't. So you've got like social media companies and gaming and like AI as well. So yeah, people use Buildkite mainly to ship software and deliver and deploy to production, but they also use it for model training for AI. So that's pretty cool as well. So yeah, I work in the test engine team. So test engine is a product that helps speed up builds by helping teams understand their test suite. If you think about what this core CI/CD product does, it shows you the results of a single build at one time. So you see all your tests and whether they're passed or not. What test engine does is it aggregates all of that data in one place. And so that's a lot of the data that we have to, store and present back to the customers in a UI and a dashboard. Some of the things that we do in test engine is like flaky test detection, so we can tell the customers whether the test is flaky. We do things like test splitting, so we use the timing data and build a test plan so customers can distribute that test suite across many nodes to speed up their tests. We also do test management and workflows, so we can help teams disable a test, quarantine a test, so the builds won't get blocked. So yeah, it's all about helping teams build and deploy as fast as they can. So yeah, here's a quick list of things I'll be talking about today. My colleagues Ming and Paul, they were very involved in getting ClickHouse into the test engine stack, and they helped me prepare this presentation today. So yeah, acknowledgement for them. So yeah, just a bit of background about test engine, how we got here, and how we're using ClickHouse today. Just need my notes. So yeah, when we launched test engine a few years ago, it was a very simple stack. We had Ruby on Rails as the application sitting in front of a Postgres database. It's very simple. It was great at the time just to get started and to launch, but then we recognized that we need to scale the platform. Customers wanted to use this product, and we couldn't onboard them due to our platform at the time. So we re-architected the ingestion platform to migrate us to from syncing our data to Postgres, and started using other systems for processing and pre-aggregation. So in 2024, our data architecture we started to use Kafka and to propagate these records in Flink to pre-aggregate them. And yeah, we using a bunch of different data stores that wasn't Postgres to make these aggregations work. And then what we did was that we took these aggregations and these individual records and made them available to the user-facing application. So this was like a 6-month project with a small team last year, and we got that done. We unlocked the platform for large enterprise customers. They could onboard onto Test Engine, and everyone was happy. But then customers wanted more from the platform. So this is where we are today, maybe a few months ago. So our customers had a really strong demand to leverage their data in a way that's intuitive to them. So not just us presenting like a canned report to them, like a pre-aggregation. They want to be able to arbitrarily apply metadata to their test results and then unlock the potential for them to come up with their own solutions with our platform. So the problem is that customers wanted to apply like attributes or tags to test results, and then be able to use our platform to analyze the data, filter, grouping by these attributes in arbitrary combinations. So no, we can't really pre-aggregate or pre-calculate these views for them. So we had a few other systems that we tried and used, but they weren't really fit for purpose. I'm going to talk about a few of them right now. So I mentioned Flink before as for stream processing. It's good for like making user rules-based actions. Not very good for like aggregations across lots of arbitrary user-specified tags. I mentioned Postgres before. We were storing aggregations in them, but we no longer store like the raw executions. It's just way too much data. DynamoDB, we store executions in DynamoDB. It's good for fast retrieval of like individual records, but not really capable of doing like real-time analytics. We also use Iceberg, so we sync data into S3 and Iceberg format, and we use Athena to query that data, which is reasonable. Like it's good for flexible querying, but it's not fast enough for our needs. Definitely not fast enough for customers. What we also tried to do was spin up a Trino cluster, hoping that would be a bit faster than Athena, but we didn't really get any good results from there. I mentioned Kafka, another type of technology. It's fantastic for like storing the data and piping it between different components, but it's not really designed for like this type of querying or aggregation that we wanted to do. So this is an example of this is an example of a test execution. So in our UI, so you have this test that failed. You know the git commit shard, the branch, the error message, the duration, and the bit in the middle is the tags. So we wanted customers to be able to like specify arbitrary tags use those tags like to do grouping and aggregation, that sort of thing. So some examples here, you can see like a build ID. What else do you have? Like a host type, instance type, architecture. Like language version, so like you might run your test against different versions of Ruby, which is what we use, or you might have different versions of Rails, or you might have different versions of Postgres you want to test your test against. So you have to get all that metadata tagged against your individual tests. Is quite exciting. So yeah, we started our journey last year to solve this tagging problem. So this is like an internal blog post by one of our colleagues, Ming, in November to document our investigation. So it's no surprise to everyone that we chose ClickHouse. And here are some of the reasons why. We were biased towards certain things. But yeah, I think the other speakers, Johnny and Peter, mentioned that, yeah, ClickHouse is just really fast. I was really impressed by, I think the founder, Alexei, he gave a talk a while ago about how he made it so fast. And he talked about like bottom-up design and designing for the hardware, and talking about like all these tailor-made algorithms. So like having all these different algorithms and data structures designed for specific tasks, and then benchmarking them like in your instance, and then deciding, which is really interesting and cool. Yeah, I won't go on too much about all these individual attributes, but yeah, it was just really easy for us to test this locally and like actually prove that it was really fast, really quickly. We talked to other friends in other companies in the industry, and they all had good things to say about ClickHouse. So yeah, we were pretty happy with the social proof. Peter mentioned the new JSON data type. That was like really the key for us, like the ability just to send metadata into this JSON data type, and then having ClickHouse to like to create individual columns for each key for us was like just really amazing. Let's see, let's go to the next slide. So how do we evaluate and onboard at a very high level? So I mentioned before, we just tested it locally. We just downloaded the binary, ran it on our machine, sync some data from production, and yeah, gave it a go. And then we moved up to spinning up an instance in AWS. And we actually prototyped something for a conference, AWS reInvent. So our customers were pretty excited by that prototype. So we had to look at productionizing that solution. We looked at ClickHouse Cloud. I think that we're pretty happy with that, because we didn't really want to do a lot of operation stuff. We don't want to worry about updates and patching, scaling and that sort of stuff. ClickHouse Cloud was a good solution. It was a good trade-off. We connected with the ClickHouse team, I think maybe last year in December, maybe, I'm not sure. Buildkite teams, legal, risk and finance, gave us the approval when we loaded the credit card in, and we started becoming a customer late January. We've been moving quite quickly. So now we've been ingesting billions of test executions every month, which is pretty exciting. I know we're still on the small side of things, but it's really it's giving us a lot of room to grow into. Flink is still vital in the architecture. We learned that's quite good for doing action-based. Action-based, doing things based on actions, like rule-based things, so like detecting flaky tests, doing stateful processing. But it's not very good for what we wanted to do. So ClickHouse really was a better fit for us for on-demand querying by arbitrary dimensions. So you might be able to see this. So this is an example of the UI. So this is a view of a single test, and there's that test trend section in the middle where some of the data has been grouped by the host type. So this slide here shows you a graph displaying the P50 test duration data. So when I say instance type, that's like a machine that you run your test on. So each machine type has like different CPU and memory. The M5 and M6, M7, that sort of denotes the generation of instance. So the M5 would be an older generation, and M7 would be a newer generation. As you can see in the chart, that orange line, the test runs about 4 seconds. That's the P50 duration, and the M6 generation runs about 25% faster. And I did look up the cost of those instances, the M5 and M6, and actually the M6 is either like cheaper or like at the same price as M5. So it's like this is like really cool insight. Like the customer would say, oh, we can save a lot of money by changing instance types. The same thing can be done with architecture and that sort of thing. But yeah, it's just really interesting how customers can now use the data that, in ways that they couldn't do before. So yeah, what's next? Does anyone know where this GIF is from? Yeah, good show, right? Yeah. You can probably tell I'm a fan of that show. So what's next? We're looking at leveraging ClickHouse to deliver more analytical capabilities for our test engine customers. So we spent a lot of innovation tokens. So before I mentioned we introduced Flink and Kafka. We started using Java at Buildkite. So that's a lot of innovation tokens that we spent. So we're actually looking at simplifying our stack now and reducing or possibly retire some of the technologies we introduced. So Peter mentioned that DynamoDB is good for some things, but not really good for real-time analytics. And so with ClickHouse, that may have that might become unnecessary. So DynamoDB might be something we remove or reduce our reliance on. Something else I should mention is that we still have a simple setup in ClickHouse. We just have a single table. We're not doing any joins or anything like that. We haven't looked at performance optimization. We haven't really invested in that. Things are quite adequate at the moment, but we know that there are other things that we can do. We could probably look at our data types, look at our schema, revisit our primary key decision, and then look at things like projections and materialized views in the future. Buildkite's quite a large engineering team. Test engine is very small. So we're the only team that's currently using ClickHouse at the moment, but other teams at Buildkite are closely watching what we're doing. Just to quickly wrap up, we hoped at the time that Flink would solve all our problems, but it turns out that's not true. It's good at rule-based actions, like sending notifications to other systems, detecting flaky tests. Flink is good at piping data between different systems, like syncing data into Iceberg, DynamoDB, Postgres, and even ClickHouse. That's what we're using Flink for at the moment. ClickHouse is what we wanted, allowing customers to make flexible querying across all sorts of user-defined dimensions. So we've been pretty happy with our adoption of ClickHouse Cloud. It's unlocked lots of customer value. Customers can now do things that they couldn't do before, and our customers are very delighted. We're looking forward to using ClickHouse more to serve more of our customers' analytical needs in the future. So yeah, just to quickly, before I end, some practical tips. The quick start guide at ClickHouse is really a great way to just get something running in like a few minutes. You just download the binary, start the server, start the client, sync some data. You can probably get it done in like 5 minutes, and you can just start playing around. It's very easy. You can either sync your own data that you already have. There's lots of table engines and integrations, so like wherever your data is, you should be able to find a way to like get it into ClickHouse very quickly. Alternatively, you could either just use an open data set. So ClickHouse has a bunch of examples on their docs that you can play with. Learning, yeah, I really highly recommend like the live training. I did the foundational one and the query optimization one. They were really handy and useful. Like with any technologies, I would recommend that you have some mechanical sympathy, like understand like the technology, how it works, at least at a high level, so you can like understand its limitations and get the most out of it. So yeah, some things I would recommend. I think Peter's mentioned that before, like making sure you choose the right data types. Try to avoid nullable types. Use low cardinality where it makes sense. Choosing a primary key. Those are kind of the things I would recommend that you do. Obviously, you don't need to know this to get started, but I think to get the most out of it and to make your queries run really fast, you may want to invest a bit of time learning that. Yeah, and that's it. Thank you so much for listening.